So this video is going to go over kinetic molecular theory, also sometimes abbreviated KMT for kinetic molecular theory. We're going to look at how kinetic molecular theory specifically pertains to gases. And so there's 5 different pieces of the kinetic molecular theory. First piece, gases do not attract or repel. So this means that there are no attractive forces between gas particles. This is part of the theory that makes some of our laws a little simpler. Now, it is not necessarily always true. Sometimes there are attractions between gas particles. However, to simplify things, we are going to say that gases do not attract or repel each other. Second piece is that gas particles take up no space. This means that the particles themselves don't occupy any volume. We know that this isn't true because all matter occupies some amount of space. However, since the particles are so incredibly tiny, we're going to say that they don't occupy any significant amount of volume. Therefore, the volume of the container is the actual volume of the container, and we don't have to account for the volume of the actual gas particles themselves. So, there are no attractive forces between gas particles. They occupy no space. Gases move in straight, random lines. Okay, so what this means is that the particles themselves don't weave around each other. It means they're going to go in a straight line until they hit something else. Once they hit something, then they're going to move and go a different direction, but otherwise they move in straight lines and they move completely randomly. So this kind of goes back to the forces. There's nothing that's pushing the gas particles around themselves. They're going straight until they hit something, whether it's another particle or the wall of a container, and then they're going to go in a different direction. The next thing is we're going to look at how they actually collide. So the fourth part is that no energy is lost in collisions. So this means they're also referred to as elastic collisions. So that means when the particles collide with each other, there's no energy lost. It's all transferred from one to another. So that's how we transfer energy, is through collisions. And all of that energy goes straight from one particle to another, or straight from the particle to the wall of the container. It's not, there isn't energy lost to the surroundings. And then the last part also deals with energy. And it says that the average kinetic energy of the gas particles is related to the temperature. This means that we can draw a conclusion, or we can draw a relationship between the temperature of the gas and the amount of average energy the particles have. Obviously, it's average, so it doesn't apply to each specific particle. There are other factors that come into play there, but the overall average kinetic energy is related to the temperature. So this helps us take the speed of the particles, the speed that they're moving, because that's related to the energy, which we can then relate to the temperature of the gas. So these are the 5 pieces of kinetic molecular theory that we use to simplify some of our behaviors of gases, so that our calculations work out well. There are things called real world. Is that what they are? No, they're just real gases, in which not all of these do actually pertain. So we acknowledge that gas particles do actually have to occupy some amount of volume. There are attractive forces between gas particles. It's the average kinetic energy. Sometimes not all of the collisions are elastic. However, for our purposes, we're going to stick with kinetic molecular theory because it keeps everything nice and simple.